Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about significance tests and decision making. All right, a significance level, alpha, is the value that we use as a boundary to decide if an observed result is unlikely to happen by chance alone when the null hypothesis is true. In making conclusions, if our p-value is less than our alpha, then we reject the null hypothesis and conclude there is convincing evidence for the alternative hypothesis. And we would state that in context. So we would kind of restate what the problem was about. If our p-value is greater than our alpha, then we fail to reject the null hypothesis and conclude there is not convincing evidence for the alternative. And we would also put that in context. A type 1 error occurs if we reject the null hypothesis when the null hypothesis is true. That is, the data give convincing evidence for the alternative, that the alternative is true when really it isn't. A type 2 error occurs if we fail to reject the null hypothesis when the alternative hypothesis is true. That is, the data do not give convincing evidence of the alternative is true when it really is. All right, an example, determining statistical significance. Kai loves any meal made from beef, but he suspects the school cafeteria doesn't love beef as much as he does. He believes that less than half of all meals served in the cafeteria contain beef. To test this claim, he found the menus of the last 5 years, randomly selected 50 days, and recorded whether beef was served for lunch. Of the 50 meals, 18 contained beef. He performed a significance test of the hypotheses. The null hypothesis, p equals 0.5. The alternative, p is less than 0.5, where p is the true proportion of cafeteria lunches in the past 5 years that contained beef. The resulting p-value is 0.0238. What conclusion would you make at an alpha of 0.05 significance level? All right, so our p-value is smaller than our alpha value. So we reject the null hypothesis because our p-value of 0.0238 is less than our alpha value of 0.05. We have convincing evidence that the true proportion of cafeteria lunches in the past 5 years that contain beef is less than 0.5. All right. An example of type 1 and type 2 errors. B&B controls, installs, and maintains security gates for airports, military bases, banks, and other large institutions. On average, a gate can operate for 82 days before needing routine maintenance. B&B controls institutes a new design intended to increase the average number of days that a gate will operate before needing maintenance. Although the new design is more expensive, the company would save money in the long run by reducing maintenance costs. The owner of the company selects a random sample of 20 existing gates and replaces them with gates made using the new design. An inspector will monitor the gates until they need maintenance and test the following hypothesis at an alpha of 0.05 significance level. So the null hypothesis is that mu equals 82. The alternative is that mu is greater than 82, where mu is the true mean number of days the gate with the new design can operate before needing maintenance. Describe a type 1 and type 2 error and give consequences of a type 1 and type 2 error. So I'm going to do a type 1 and I keep it to like the left side, and then type 2 I'm going to keep to the right side in your space on your paper. All right, so a type 1 error. The inspector finds convincing evidence that the true mean number of days a gate with the new design can operate before needing maintenance is more than 82 days. All right, so in a type 1 error, we reject the null hypothesis. So we're going with we have convincing evidence it lasts longer than 82 days, but it's an error, so when really it's 82 days. So when in actuality, that's not the truth. All right, a consequence. So the company installs the expensive new gates. That doesn't save money in the long run because the maintenance cycle isn't longer. All right. A type 2 error is when we fail to reject the null hypothesis, but we are wrong. So if we fail to reject the null hypothesis, that means we do not have convincing evidence. So the manager doesn't find convincing evidence that the mean number of days a gate with a new design can operate before needing maintenance is more than 82 days, when really it is more than 82 days. So the consequence here would the company would not install the gates with the new design, and they'd be missing out on that long-term savings in the long run. All right, go Seahawks.